Here we have another diagram on the Earth Science Reference Table. This one is the scheme for sedimentary rock identification. Remember, the first thing we always want to do is to read the title of any new table or diagram. So there we go. And the first thing you should notice is that there's kind of two main parts to this diagram. There's the upper part, which has this label inorganic land-derived sedimentary rocks, and a lower table which is the chemically and/or organically formed sedimentary rocks. The primary difference between the inorganic land-derived sedimentary rocks and the chemically and/or organically formed sedimentary rocks is their method of formation. The rocks on the upper part of the table come from pieces of other rocks. That's what this word clastic or fragmental means. So the textual term clastic means that it's made of pieces of other materials that are compacted and cemented together. And then the chemically and or organically formed sedimentary rocks, you'll notice their textures are either crystalline or they are bioclastic. So that means they form through some sort of chemical means, or they are created through living organisms, whether those are plants or animals. We should first look at our column headings. We have texture, grain size, composition, comments, rock name, and then a new column, a new entry here that we didn't see on the igneous rocks. We have a map symbol. All right, so this far right-hand column of map symbol is a agreed upon symbol that's used worldwide to denote these different types of rocks. So you might be wondering, how do we read information off this chart? So let's take an example. Let's imagine we want to look at the rock sandstone. And we want to know all about sandstone. So first thing we can kind of surmise, it's in this upper box, so it's an inorganic or land-derived sedimentary rock. Its texture is clastic. That means that it's made out of pieces of other material. And we can see in the grain size column that those materials are sand sizes. So that's between 0.006 to 0.02 centimeters in size. Right? In terms of composition, a sandstone is going to be mostly quartz, maybe some feldspar and clay minerals, and it may contain fragments of other rocks and minerals. Looking at an example from the bottom of the chart, under the chemically and or organically formed sedimentary rocks, we take a look at rock gypsum, the second entry. Under comments, you'll notice it says crystals from chemical precipitates and evaporites. Rock gypsum, rock salt, and dolostone all precipitate out of seawater. So there's dissolved minerals within water. When the water evaporates, it leaves behind the solid crystals. That's very similar to making rock candy, where you can dip a stick in sugar water and let the water evaporate slowly over the course of a week or a few days, and you're left with sugar crystals on the stick. And so you'll notice the texture is crystalline, and the grain size has fine to coarse crystals. And the sizes here would correlate to the sizes found on the igneous rocks chart. You'll notice that limestone is made of the mineral calcite. Something interesting about calcite is that it will bubble with acid. So there's a number of questions that relate back to this unique property. Because calcite bubbles with acid, it dissolves in acid. Limestone is a big former of cave systems around the world. Limestone can be either crystalline or bioclastic. So a crystalline limestone will not contain any shell fragments. Crystalline limestone will precipitate directly out of seawater, whereas a bioclastic sample, you will actually see seashells and remains of sea creatures in that limestone. Last but not least, bituminous coal. This is the only rock on the reference table that is made from compacted plant remains. It's a very common fuel source. It's one of the fossil fuels that is burned for electricity.